So in the last lecture, I think we have discussed regarding the reinforcement spacing between bars. So in that we have discussed regarding the slab, right? That was 3D and 300, whichever is less, and 5D and 450, whichever is less. Now requirements of reinforcement for slab, beam and column. So that is given on page number 48, clause number 26.5.2. Reinforcement requirement for the slab. Now the minimum requirement for the slab, that is for minimum requirement of reinforcement for mild steel. If we are using the mild steel, then if we are using the mild steel, then the percentage steel, minimum percentage steel, that will be 0.15% of total total cross section area. So here it is essential that suppose we have the beam, singly reinforced beam, and reinforcement is provided at the bottom. So overall depth, that is capital D, and the width is small b, and at the center of the reinforcement, that is called as the effective depth. So here you have to consider the overall cross sectional area, that is b into d. So if you are using Fe 250, then you have to take minimum 0.15% of b into d, and if you are using 415 or 500, then pt will be 0.12% of the cross sectional area. Now why minimum reinforcement is required? So it is used to prevent the excessive local curvature, to provide the resistance to the shear, and to provide the resistance to unforeseen forces applied during the construction. Then the maximum diameter of bar. So maximum diameter of bar should not be less than 1/8. See again, the D is a overall depth of the beam. It should not be 1/8, right? It should not be 1/8 of the overall depth of the slab. Then minimum diameter. Minimum diameter, that is, this is the maximum diameter of the bar, and this is the minimum diameter of the bar. For the main bar, if you are using the plain bar, then the minimum diameter will be 10 mm, and if you are using the deformed bar, then minimum diameter will be 8 mm. It means that you cannot use the reinforcement bar having the diameter less than 8 mm for deformed bar, and 10 mm for your plain bar. Now for the distribution bar, the minimum diameter is 6, but now it is revised, it is 8 mm. You cannot use the reinforcement less than 8 mm. Then reinforcement requirement for the beam. So reinforcement requirement for the beam, that is given on page number 46 and clause number 26.5.1. So minimum tension reinforcement. So the area of tension reinforcement, the equation is AS upon B into D is equal to 0.85 upon Fy, right? Where AS is a minimum area of tension reinforcement, B is the width of T beam, D is the effective depth, Fy is the characteristic strength, and minimum tension reinforcement in percentage. So see, if you put Fy is equal to here, if you put the Fy is equal to, if you are using 250 grade uh, steel, then put 250 here, and you will get As upon BD, As upon BD 0.85. Here it will be a 250. So it is something like that, 0.0035. It means 0.35% of the effective area of the beam. If you are using 250 grade, 415 grade steel, then it will be a 0.20% of the effective beam. Now maximum tension reinforcement, that is not more than, should not be more than 0.04 B into D. That is a 4% of the total area. So you cannot provide the reinforcement more than 4% of total cross section area, right? So this is the maximum tension reinforcement, and maximum compression reinforcement should not be more than again 0.4 B into D. Now the side reinforcement, that is side face reinforcement, that is when the depth of web exceeds 750 mm, side reinforcement is required to be on the both side of the web, right? So if we have the T beam like this, and this web is more than, is greater than 750, then you have to provide the reinforcement, side reinforcement, right? You have to provide side reinforcement. The total area of side face reinforcement is 0.1% of the web area, right? Of the this web area, right? This web area, that is 0.1%. To calculate, the steel is equally distributed on the both sides. The total calculated steel is equally distributed on two faces. The spacing of the side face reinforcement shall not exceed smaller of 300 mm, or web thickness whatever is smaller, that will be a value, and it should not be more than, it shall not be exceed that smaller value. Now shear reinforcement maximum spacing of the shear reinforcement is 0.75 D for the vertical stirrups, and 300, not greater than the smaller of these two. So whatever the smaller value, you pick up the smaller value of 0.75 D and 300 mm, whichever is smaller, that will be taken, and your spacing, it should not be greater than this smaller of these two values. Then minimum shear reinforcement, ASV upon B into SV, is greater than or equal to 0.4 upon 0.85 Fy. So through this, you can find out the minimum shear reinforcement, that is total cross-sectional area of the stirrups. So stirrups are the link, like this type of the links, that is mostly provided in the beam and the column. So you are just holding the bars right in the place by using this type of the ring. So you just bend it like this, then bend it like this, then bend it like this, and you bend it like this, something like this. Here you have the reinforcement. So the ring is used to tie up the bars, longitudinal bars. Now reinforcement requirement for the columns. So as you know, the vertical reinforcement in the column is called as the longitudinal bars is called as the longitudinal bar, and the horizontal column is this bar is called as the lateral lateral reinforcement. So for the longitudinal or the vertical bar, a cross sectional area of longitudinal reinforcement shall not less than 0.8% nor more than 6% of the gross cross sectional area of the column. So the gross cross sectional area of the column, suppose we have the column having 300 mm width and length is suppose 1000 mm. So the total area is 300000, means 3 lakhs mm square. So according to this, your minimum area of steel is 0.8% of 0.8% of this